All right, so on this review here, again, very first things we did, like the first like 17 to 20-ish, we just talked about vector operation, and then since lesson 20, we really got into the word problems or aspects of them. So what I'm going to do on the test is I'm going to give you two different vectors. Remember, this is vectors. These are not coordinates. Know the difference. These are the little inequality symbols versus those parentheses. Parentheses would indicate a point. So these are vectors. Be able to multiply scalars to vectors and to be able to add and subtract vectors. So let's practice that if you haven't already done it. So if I wanted to find out what 3a is, I'm literally going to write 3 times the vector of a. That's a 15. Hold on. I got ahead of myself. And so what I'm going to do is I'll distribute to each part of the vector. So what's my answer? Perfect. Have we already finished these? All right, let's then check it. Awesome. All right, here we go. 3, -5, and then plus 2, 4. Remember, just like in matrices, we add their corresponding values. So in this one, this is going to be a 3 plus a 2, and that gives me -5 plus 4. Good. All right. A minus b. So this would be 3, -5, minus 2, 4. Read it from left to right. What is 3 minus 2? -5 minus 4. Very good. Still good? All right. This would be 2 times 3, -5, plus 4 times 2, 4. Again, distribute to each element. So this would be perfect. This would be perfect. And then actually add them. So 6 plus 8, -10 plus 16. Any questions? So everyone's going to make at least a 25. Awesome. All right. Give you some time to write this next one. Next thing we talked about was translating unit vectors. So we got a vector t, and then you were given a linear equation, and I want you to write the image of the line under this translation map, and I'll show you what all this means if you don't remember. I'll give you time to write down. I would have printed this out for y'all, but having time to print is a challenge. Yes, ma'am. It was 5, but I took the Stonebridge question out because I just didn't want to go over it and just took it out. I feel like that's a great physics question. It was lesson 21 or something. Yeah, it was the one with the trapezoids in it and talked about the force and stuff. Great question for Whiting, just not where I wanted to go with the lesson. Everyone had time to write this out. All right, so what this question is basically asking is, here's a linear line right here, and here is a vector t. If I was to apply this vector to this linear line, what would its new line be? So here's the process of doing that. For starters, we are more familiar with our linear lines in what form? Y equals mx plus b. So let's start there. So our first step here, we're going to take our x plus 4y equals 12. Let's solve for y. What did I do first? Yeah, very good. Minus x. Remember, we're trying to get it in y equals mx plus b. We don't want to move the y. We want to move everything else but the y. So we're going to subtract the x. I like to keep it in this form. So when I rewrite this, this is going to be negative x plus 12. If you wrote it as 12 minus x, you're not incorrect. It's just not, maybe not as easy to identify. What's your next move? Good. You're going to divide every term by 4, not just the x, not just the 12, but every single one of them. I'm going to rewrite this as negative 1/4. That's going to give me that rise over run. I can see it a little bit better. I don't have to worry about remembering if there's a 1 or not. And then 12 divided by 3 is? Yeah, my bad. You're right. 12 divided by 4 is 3, not 12 divided by 3. Gosh. All right. Anyways, so now we have a little bit more familiarity. What's the negative 1/4 represent? The slope. And what's the 3 represent? Y-intercept. How's the y-intercept written if I wanted a coordinate? 0, and then whatever the number is, in this case, 0, 3. All right, if I want to apply this vector to this linear function, all I have to do is take this point, we're going to write it in this notation, just add the vector to it. So in this case, negative 3, 2. One more time. Oh, I like it. We're going to call it step 2. Right? So I'm going to take that y-intercept. Now, theoretically, you can actually pick any point that's on this line. So if you wanted to do some calculations and find a different point, as long as it's on this line, this process will work. I find this to be the easiest because it just gives us a point right off the bat. All right? But either way will work. So applying this vector to any point will shift it over in any direction. So if I was to take this random point on the line and apply the shift, where's my new point going to be? All right. So now that you have a new point that has been shifted from the old line, this is your x and this is your y. We can take that and plug it in to figure out what is it now equal to. So here's the third step. I'm going to take the original equation and I'm going to plug in my new point. The goal is to get a new equation. So I'm going to go with negative 3. Oh, that's not, doesn't look like a 3. So negative 3 plus 4 times 5. And then we just work it out. What's 4 times 5? What's negative 3 plus 20? 17. Go ahead.
We just dropped the 12.
Yes, because now I'm going to get a new result. Technically, what we did in the book is we actually plugged it in here to calculate a new y-intercept for us to write the equation. But on the test, it's going to keep it in standard form. So instead of us having to plug it in this, get the slope-intercept form, and then rework it in standard form, I'm going to skip about 2 or 3 steps. We're just going to plug it straight into here to get that value so we can keep it in this form. Right? So therefore, once you have whatever this value is, this part won't change. So my answer will just be x plus 4y equals the new number. And that'd be it. So again, in the book, when you go back to it, we plugged it back into this, worked it down, got it that way. But on the test, it keeps it in standard form. So to save you about 2 or 3 steps, we can keep the left side the same once we find out its new constant. Take it in. The x plus 4y, because it was right here. Oh, gotcha. All right, so I replaced x with negative 3, and I replaced the y with the 5. And then I just worked it out. That's a good question. Solid. So we're making a 50 on the test. All right, good, good. All right. All right. Let's look at the next one. Of course, I'll give you some time. We also talked about parametric equations. So that was the vector equation form. This is the parametric equation. We're given an equation. Can you give me the parametric equations? Give you time to write it down, and then we'll work it out. You are struggling and you don't want to say it out loud, I will be here for tutorials today. Sounds good. I'll give you more examples. I got you. Well, I liked David's approach. First step, second step, third step. So kind of loaded. Sometimes if I get to write that, I just work through the process and forget. There's steps here. All right, ready? All right, here we go. So it's a quick question as long as you know what you're doing. So remember, when we were working these questions out, the first thing we did is we took it into vector equation form. And then from the vector equation form, we then wrote out our parametric equations. After we did it a few times, some of you are like, do we have to do that middle step if we just know the answer? You don't. But if you don't remember it, I'm going to write it out anyways. But if you can follow along, I'm good either way. All right, here we go. So to write this in the vector equation form, remember it was x, y equals, and you know what? I'm going to keep it the format of how the test is. This is going to be x of t, y of t, which I think is your textbook too. I always forget to write it in function notation form, equals the x1, y1, whatever the point is, plus your vector, which was a and b. So this was your vector times t, right? This was our vector matrix equation. Now, a couple things. We talked about vectors are a and b, basically represent our slope, but slope is written how? B over a. So in this situation, well, before I go any further, so this slope right here, this would basically be your b, this would be your a, but what is this number again? Y-intercept. How's a y-intercept written? Perfect. 0 and then whatever the number, in this case, -3. The sign goes with the number. So you're not given a point, but you can pull a point out of it for this x1, y1. All right. Once you have all your information, we're just going to rewrite this. So x of t, y of t would equal the point, and I'm going to choose the y-intercept. But just like in the last question, you can technically pull any point that's on this line, and it will work. So this will be 0. This will be -3. Plus, again, my vector is AB, but the slope is written as BA. So in this case, how's my vector written? 2, 1. Very good. All right, so make sure you switch those. So B over A, but the vector is written as AB. Okay? And then your T. You still good? All right, to put it in the parametric equation form, this is then where we separate these as two different equations. Well, that's super awkward. Gotcha. Are y'all seeing a pink line show up? All right, cool. All right, so we're just going to write this out as two equations. So this again becomes x of t equals 0 plus 2t, and then y of t equals -3 plus 1t. I told y'all when we did these notes, I would totally accept this, but on your tests, it's going to have the simplified answers. So how should this be rewritten? Good. We do not need the 0 plus. How would this one be rewritten? You don't need the 1. -3 plus t. Perfect. So even though this is technically correct, this is what you'll see on the test. Are we good? Jacob? Okay, okay. So we did a lot of these examples. I think this was all over lesson 20 and 22. And then, of course, we did the applied part. So we're making a 75 at least. All right, let's get into the question of the day. All right. There you go. So this one's a position of a drone. They're going to give you the vector equation or the matrix vector equation form. It's going to simply just say, how far has the drone traveled when it reached a height of 130 feet, and then round to the nearest foot. So I'll give you a chance to write this out. They definitely made the word problem on this one way easier than the whole map thing, where we're trying to find the current of the water or the current of the wind. Now, you might see that on the unit test, but we're good here. I'm thinking about making that the final.
Okay,
Yeah. I don't know what your attendance is. No, I'm going to make the unit test the final. That's where I'm heading with it. I'm still going to have another test over lessons 25, 26, 27. But I think that final unit test is going to be the final exam. Yeah. And that will be over this entire semester, which is lessons 1 to 24. I don't know how they expect me to get more than one module in a semester. I don't know. Lessons learned. They do, like they expect you to like know it all, like the moment you see it for the first time. Yeah. So they like expect you to like just keep going and going and going and going. I'm like, I've done that before. I did that because I was real curious. How do I get it all in? And the kids had a basic foundation of everything, but couldn't go deep with it. Where I feel like here, I feel like you can go pretty deep in these topics. Yeah, you didn't get to see the rest of it, but if you ever take college pre-cal, you'll see it then. Or college algebra, you'll see it then as well. Or you won't use it. I mean, depending on your degree. No, this is a lot harder than college algebra. College algebra, think of it as you remember algebra 2? That's college algebra. But like instead of a year, 16 weeks. Yeah, it's not harder than college algebra. Yeah. You still got your book? Yeah. All right, we ready? Oh, good. Okay. There we go. All right, so this is the process of answering questions like this. So again, we have a position of a drone that's represented by a vector matrix equation. And it just simply wants to know how far has the drone traveled when it reaches a height of 130 feet. Now, on the test, it goes a little bit more specifics, and it tells you what x of t represents, what y of t represents, and what z of t represents. The x of t is going to represent your distance from east to west. Your y of t is going to be your north to south. And then your z of t is going to represent the height of wherever you're located. All right. So this right here, again, is going to be how much you traveled up the left and right, how much you traveled up and down, and the z is just going to represent the height at any given time or wherever you're located. All right. So they're going to say that on the test. But that's pretty much what this is going to be. So here is the process. Step 1. You technically have 3 equations here. Since we are looking at how far has the drone traveled when it reaches a height of 130 feet, this is going to represent your z of t. All right. So to do that, I need to take the z of t equation, which is written as this. Before I move on any further, everyone understand how that became my z of t equation? Okay, so once I have that, I'm just going to simply replace the z of t with 130 and solve for my time. Once I know my time, then I can go back and I can substitute it in for either x or y to find out my location. Go ahead. Oh, because it's 2 plus t times 8. Now, granted, you could say t8, but it's grammatically correct to say number than letter. But you're not incorrect by saying t8 either. So, okay, here we go. So I'm going to replace z of t with 130. How would I solve for time? Subtract 2, get rid of that constant first. So 130 minus 2 is, then what? Divide by 8. I have no idea. Ooh, nice clean number. 16. I think on the test it does tell you like time is seconds. So basically it would be this drone is 130 feet in 16 seconds. Right? Now that we have our time, now we can figure out our distance traveled. Yes. So now that we got our time, all we got to do now to find our distance traveled. This is hard to draw because it's three-dimensional. But now that we know our distance, let's pretend this is that three-dimensional shape. My drone is somewhere over here in space, right? It's moved X, it's moved Y, it's moved Z. I'm trying to figure out how much distance did it travel? What does that mean? Go ahead.
Now we have used X, Y.
We actually are, the X and Y and Z has already been in use. The only information that was given to us is the height. The height represents the Z. So I at least now know how high off the ground I am. I just don't know in space, where am I at, east to north, south to west. That was way backwards. East to west, north to south. I just don't know that part. I just know now that I have a time, 16 seconds after this drone has gone off, I need to find out that total distance. And I'm looking for the total distance. What am I looking for? Which is no. Okay, but it's three-dimensional, so it'd also be C. That's fine though. Yep. You're finding that magnitude. So if you're finding that total distance in space, its magnitude, which was for three-dimensional space, was the square root of a squared plus b squared plus c squared. So to get the correct A, B, and C, I'm going to take this equation right. Go ahead. Yes, it is. Step 2. I'm going to take this equation right here. I'm going to take my starting spot. In space, he was 10 to the right, 3 down, and 2. I don't know how to do three-dimensional space, but this is where he's located in space. So that's 10, -3, and 2. And then the slope of the drone, he's moving right 6, up 1, 8 in the Z. All right, so this is my starting, this is my slope. Now I know the time at which it hit 130 feet. So instead of a T, I'm going to plug in my 16. Mm, that's it. Okay. So what this happen? Okay. We're trying to find this distance by using this formula. If we go this direction, this is where I don't know where I'm actually located. Let's say that's where I'm located, and we moved over here. That would be my magnitude. The issue is to use this coordinate right here, I would now have to do x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. And that seems like a lot of work. But we've learned that we can take a vector and we can move it there. So if I know this is the distance that my vector has moved, I can actually take the original point out. And I'm basically what I'm going to do is I'm going to say, what if the original point was 0, 0, 0? So that I can apply this formula rather than this formula. All right. So instead of multiplying by 16, then adding the where we're at, we're just going to look at the distance traveled. So in this case, 16 times 6 would be what? Thank you. 16 times 1, 16 times 8. All right, so now this is what the vector had moved in 16 seconds. So now I'm ready to do 96 squared plus 16 squared plus 128 squared. Had you done this process, you would have got these values, and then you would have to take those values minus this value squared. This minus that value squared. This minus that value squared. And then what happens is you end up adding and then subtracting away anyways. So instead of doing that, we can just start with the 0. I have no idea what you get here. Bless you. So nearest foot. What's the tenths place? And then feet. There you go. So even though it's 130 feet up in the air currently, displacement purposes, it has moved 161 feet. There you go. So again, you could go this route, but again, you then have to apply this one. So it's a lot easier just to take our vector, move it to the origin. So you're just playing with this part here. Go ahead. Do what? The original point? Yeah, because mathematically what you would do is you would get these numbers, and this would technically be like your x2. Well, you would then add 10. So this is what's going to happen. You took this and you got 106, right? All right, that's your second point. Then you would have to subtract it from your first point. Well, what's 10 minus 106? 96. Same concept here. You would do 17 minus 1. Well, you're back to 16. You would do 136 minus 8. Well, you're back to 128. And then that's what you're squaring because you're taking the original point and the new point after 16 seconds, finding that distance. Once they'll doing that, we can just delete it. That's what I was just noticing. That's why I paused because I was like, man, there's a step we did twice in there. So if you just take that and you move the vector here, I can just go, all right, well, it's just going to be d squared. Basically kind of took a step out of there to help you out. Any questions like that? So do we think we could make 100? Potentially. All right, cool. That's all I got for today. You're right. Sorry. Technically, you could say this is the third step. Yeah. Oh, yeah, I'm definitely going to